So most of you have put C, ionic bonding. Yes, it is ionic bonding. It's when electrons are transferred to one another. What does ionic bonding, what type of substances does it happen between? Do you guys know? There's two different types of elements that ionic bonding happens between. Does anyone know? Let me know. We can add it to our notes. So it occurs between, yeah, well done guys, metals and non-metals. And we said from that question that involves the transfer of electrons. Whereas covalent bonding, if we go on to our next question, in covalent bonding, atoms, so they don't transfer electrons because that's for ionic bonding. What do electrons do in covalent bonding? Give, no, give is the same as transfer. So it's not, it would be sharing of electrons. Yeah, the answer C for this one. For covalent bonding is all about sharing electrons. And what does that happen between? So ionic is between metals and non-metals. Covalent, what about covalent? Yep, between two non-metals. Amazing, well done guys. So that was the answer for that one. Metallic bonding is characterized by, what's the key thing in metallic bonding, do you think then? A, B, C or D? Put your answer in the comment and tap on the screen a few times once you've done so. Yeah, I'll keep going. I'll keep switching between the pages, don't worry, because I'm going to keep going back to the notes, back and forth and adding to it. And then I'll upload it on YouTube, so don't worry about not seeing it. C, a sea of delocalized electrons. Yes, that is what metallic bonding is all about. So if we go down to our notes, metallic bonding, so that's obviously between a metal and a metal because it's metallic. So between two non-metals, sorry, two metals, and you have positive ions surrounded by a sea of delocalized electrons. Okay, so always mention that when you're asked what metallic bonding involves. So this is our positive ions from our metal, and surrounding them we've got these electrons which are free to move. They're delocalized, and we'll come back to this diagram in a second. You don't have to draw the box. No, don't worry about drawing the box. All right, we've got an exam question next. So we have chlorine, we have hydrogen. We've got chlorine has 7 electrons in its outer shell. Hydrogen has 1 electron. So here they've added 2 electrons here as crosses. So that means chlorine is in total is going to have 1, 2, 3, 4, 5, 6, 7 electrons. Hydrogen is going to have to be dots because we have to use a dot and cross diagram. You can either draw a dot or a circle, I guess. We'll use a circle because it specifically says so in the question. So how many are we going to have in the middle? So this is, first of all, can anyone tell me, is this covalent or ionic or metallic bonding here? Covalent, metallic or ionic bonding? Covalent, good. The way we can tell it's covalent is because it's hydrogen chloride. That's one way. It's 2 non-metals. That's what I said covalent's all about. It's 2 non-metals. Another thing is this diagram. Whenever your diagram, your dot and cross diagram looks like a Venn diagram, it's covalent because in the middle here you show the electrons being shared. So if we go back to our notes, you'd have 2 atoms with a overlapping section in the middle. So if we wanted to draw something like, let's say chlorine, Cl2, where there's a chlorine atom here and a chlorine atom here. Chlorine has 7 electrons on its outer shell. So 1, 2, 3, 4, 5, 6, 7 crosses should be on the left. 1, 2, 3, 4, 5, 6, 7 crosses on the right. How do you know how many electrons are on the outer shell? Because you look at the periodic table, you see chlorine is in group 7. That tells you how many electrons there are on the outer shell. So chlorine has 7. So then you add 2 of these in the middle because this chlorine needs 1 to get a full outer shell. The whole aim of this is to get a full outer shell. If this has 7, it needs 1 more to get a full outer shell. So this chlorine borrows 1 from the right, and this chlorine borrows 1 from the left. Okay, so we've gotten rid of 1 electron here, 1 electron here. So that leaves us with 6 electrons on our left. 1, 2, 3, 4, 5, 6. And 6 electrons on our right. 1, 2, 3, 4, 5, 6. And now we've used all our electrons and this is stable. So this is covalent bonding. So let's do something similar here. How many electrons does, let me cross this out. So hydrogen has 1 electron. Chlorine's, we've already put 4 here. So there's 3 more left. 1, 2, 3. How many electrons go in the middle? How many electrons go in the middle here? So how many electrons does the hydrogen need to get a full outer shell? And how many does the chlorine need? Yeah, well done guys. You need 2 electrons. So we need, the hydrogen needs 1 cross. So let's take that cross, put it in the middle. The chlorine needs 1 dot. So we'll take that dot and put it in the middle. Now, what we're left with, hydrogen, there's no electrons left. Chlorine, there's still 2 left. So we'll add that in, 1, 2. And that's our diagram completed. So let's just double check this on the mark scheme. 1 shared pair in the overlap. Yes, we got this section here. 6 non-bonding electrons. Yep, we did that one. Those 2 were already there. And then we added this one, didn't we? So all of that gives us the correct answer. Let's move on to the next one. Which property is typical of ionic compounds? Let me know what you think the answer is. A, B, C, or D, and then tap on the screen a few times. Let's get some more people in here. So low melting point, does it conduct when it's solid? High melting point, or is it flexible? This is ionic compounds. Any ideas? So far we've got one answer. C, we've got someone saying B. Any other answers? Someone else said C. So just comment your answer and I'll explain. We got an A, C and B. It's definitely only one answer. It's not flexible. They're not flexible. Okay, so let's go through this. Ionic compounds. So ionic bonding, we've said. So what are ionic bonds? There's strong attraction between oppositely charged ions. So see here, sodium is in group 1. It has 1 electron on its outer shell. Chlorine is in group 7, like I said. It's got 7 electrons on its outer shell. Let me redraw that. I should draw that with a dot, because it's a dot and cross diagram. So both of these need to get full outer shells, but in ionic bonding, they both want, they need to transfer electrons. So it's not sharing of electrons like covalent, it's transferring electrons. So what happens is this electron from the sodium moves over here. If that happens, now sodium, let's redraw this. Sodium will now get no electrons on its outer shell, that's gone. Whereas chlorine will now have an extra one because it's just got one from the sodium. So now chlorine will have 1, 2, 3, 4, 5, 6, 7, just like before, but now it's got that extra cross. It's got an extra electron. And because it's got an extra electron, it's got one too many electrons. It's not an atom anymore, it's an ion, which means it's charged. An ion is a charged atom. Because it's got extra electrons, it means it's negatively charged. Whereas sodium has lost an electron, so it's positively charged. So now both of them have full outer shells, so they're both stable. And what you get between them is attraction, because you've got something that's positively charged, you've got something that's negatively charged. They're going to attract like magnets. And this attraction, we call it electrostatic attraction, and that's what the ionic bond is. So that's electrostatic attraction. And the definition of an ionic bond is electrostatic attraction between, so what are these? These are ions, but they're oppositely charged. Electrostatic attraction between oppositely charged ions. Now, what did our question ask? Which property? So what does this mean? This electrostatic attraction, okay? This is very strong. That's important. So why do you think that's important? If the electrostatic attraction is strong, what properties would that give it? It will give it a High melting point. Good. Yeah, I'll post all these slides on YouTube. So subscribe to my YouTube, and then when I post this video, I'll also post all the slides. High melting and boiling point. That's because the strong electrostatic attraction needs a lot of energy to overcome. Strong electrostatic attraction needs a large amount of energy to overcome. So, yeah, well done guys. The answer would be high melting points. Ionic compounds have high melting points. C. On to the next one. Simple molecular substances generally have. What do you guys think the answer is? Comment what you think the answer is. I will talk about intermolecular force of attraction soon. So type what you think the answer is. Tap on the screen a few times. Let's get those likes up. Simple molecular. This is a type of covalent substance. There's two types of covalent substances. Simple molecular and also giant covalent. So, simple molecular, the answer, it has low boiling and melting points. Low boiling and melting points. And I'll explain why. So, what do we say? For ionic bonding, they have high melting and boiling points. Covalent bonding, there's two types of covalent bonding, okay? Two types of covalent bonding. Two types of covalent compounds that you can have. You can have simple molecular, which is what this question was asking about, and giant covalent. Simple molecular can be anything that exists as a molecule. So we got water, methane, carbon dioxide, ammonia. These are all non-metals, yeah? So loads of non-metals bonded together. Pretty much any dot and cross diagram you draw for covalent bonding is simple molecular. So even what did we do earlier in that question? We did HCl, didn't we? That's also simple molecular. So let's explain what this means. In simple molecular, the substance that we're talking about. So let's talk about, what else did we look at? We did the diagram for Cl2 here, didn't we? See? So let's look at that diagram for Cl2. Cl2 looks like this. We've got one atom of chlorine bonded to another atom of chlorine, right? Together, they make, we call this a molecule. So together, they're a molecule because they're two atoms bonded together. So a molecule is two atoms bonded together, two or more atoms. Here, this is a chlorine atom bonded to another chlorine atom. What is this red line in between? Can anyone tell me? I'm going to draw another one while you guys tell me. What's that red line in between the atoms? It's a covalent bond. Well done. So this here is a covalent bond. So it's what we talked about earlier when we drew this diagram. See that? We got our covalent bond in between. That's our Cl bonded to a Cl. But these simple molecular substances have another bond involved. These are intermolecular forces. Where do we find intermolecular forces? So here we have another molecule. We get intermolecular forces between two molecules. So remember, molecules are the green things, so the whole thing, this whole Cl2. Whereas atoms, just one Cl atom. Between these Cl2 molecules, we get a second bond, which is intermolecular forces. So, two things. Covalent bond, intermolecular forces. So covalent bond are between the atoms. Intermolecular forces are between molecules. Covalent bonds are strong. Intermolecular forces are weak. And these notes, guys, remember, I'll upload these onto the YouTube channel. That's the difference between the two. Simple molecular substances have low boiling and melting points. Back here, we said ionic compounds have high melting and boiling points. Covalent compounds, if they're simple molecular, they have low boiling and melting points. Reason why is because these intermolecular forces I was talking about are weak. Remember I said they were weak? So you'd say weak intermolecular forces don't need a lot of energy to break. Okay, let me redraw this line as well. Okay, so back to our question. They have low melting and boiling points. Right, here. This question is about structure and bonding. We got part of the structure of silicon dioxide. This is similar to one of our diagrams. Here, see this one? This is a diagram for diamond. Can anyone tell me what the one underneath is? So this is for diamond. This one would be for not graphene because it's got loads of layers. This one's graphite. Yep, good. This one's graphite. So the question asked for silicon dioxide, this is very similar to diamond. And diamond I've put into the giant covalent section. So that means silicon dioxide is also giant covalent. It's another example of a giant covalent structure. Each oxygen atom forms 2 bonds. What is the number of bonds formed by each silicon atom? Each silicon atom. So let's look at that diagram carefully. What do you guys think? Each silicon atom, how many bonds does it form? What do you think the answer is? We got an answer of 4. We got an answer of 2. Let me know, guys. Don't be shy. Even if you get it wrong, you don't miss out anything. So we got 4. Let's think about that. So most people are saying 4 here. We got silicon. So you can see we got 1 here, 2, 3, 4. Yes, the answer is 4. 1 here, 1, 2, 3, 4. Yes, if you look here, that's got 4 as well. 1, 2, 3, 4. If you look at any of the black ones, they've got 4. So answer is 4. Let's just quickly check the mark scheme on that. Giant covalent, yep, we got that. And 4 bonds, we got that as well. Well done, guys. Which allotrope of carbon has structures of layers of hexagons? So I just showed you this one. And we just said what it is. Allotrope, can anyone tell me what allotrope is? And tell me what the answer is. A, B, C, or D? Yep, most people are saying D. Allotrope, does anyone know what that means? It's not an alloy. It's not a mixture of metals. Don't get confused between alloys and allotropes. So allotrope, they're basically the same element, but different structure. So you see all these giant covalent ones that we've got. We've got diamond, we've got graphite. This one is called a fullerene. All of these are allotropes of carbon because they've got the same structure. No, they've got different structures, but they're all made out of carbon. So all those atoms, or the little circles we've got, they're all carbon atoms. There's nothing else in there. So these are all allotropes of carbon. And the answer is graphite. Good. Diamond is hard because... Why is diamond a hard substance? Well, we definitely know it's not made up of... it is made up of single atoms bonded together, but that's not the reason why. Diamond does not have a sea of delocalized electrons. Remember, that was for metals only. What do you think the answer is? It has a giant structure. Yes, it does have a giant structure because it comes under the giant covalent section. With covalent bonds, yes, all of these lines here, every single line we've got here are covalent bonds. So every single carbon atom is connected by these covalent bonds. And what did we say about covalent bonds? We said covalent bonds are strong. So these are different to simple molecular. Simple molecular have these weak bonds in them as well. And those are the ones that get broken. This one only has covalent bonds, and covalent bonds are strong. So do you think diamond will have a high melting point or a low melting point? Every single one are covalent bonds. They're going to have high melting point. Exactly. So diamond has high melting and boiling point. And that's the reason why it's a hard substance. Because it's hard to break those bonds. So it's also going to be hard to break the substance. Right, here we've got a structure of graphite. What type of bond is labeled? So we just answered this, so you guys should be able to tell me. Covalent, double bond, ionic or metallic. The answer is covalent. Yep, easy. In graphite, each atom forms bonds with other carbon atoms as shown in figure 4. How many electrons does one carbon use to form one bond? One bond. What do you guys think the answer to that is? How many electrons does one carbon atom use to form one bond? Most people are saying 3. 3 is not the answer. I know why you're saying 3 actually. You're saying 3 because each carbon atom has 3 bonds attached to it. That's not what the question's asking. It's not asking how many bonds does the carbon atom make. It's asking one carbon atom, how does it form one bond? So let's say we got carbon. Carbon, if you look in the periodic table, carbon is here. It's group 4, okay? That means it has 4 electrons on its outer shell, right? 1, 2, 3, 4. That means it can form 4 bonds. It can form up to 4 bonds. So it can make a bond here, it can make a bond here, and here. We're just asking, this question is just asking one carbon atom used to form one of these bonds. So just look at one of these. Let's look at the top one. Let's say that's bonded to another carbon atom. It only needs, one person's got it. It only needs 1 electron. This carbon only needs this electron because the other one it shares with this carbon, isn't it? So this carbon in the middle only needs 1 electron to bond with this top carbon because the other electron it borrows. All the other 3 electrons, so this one, and this one, they're all used to bond with other atoms. For that one bond, so we basically got this, don't we? 4 different carbons being bonded. So for this one bond, it only needs this 1 cross. So the answer is 1. Yes, well done. I think you guys are getting it now. Answer is 1. So just double check that on the mark scheme. Covalent, yes, and 1 for the last one. It's a bit of a tricky one, the last one. I think it's a bit of a trick question. Let's move on. Next one. Graphite conducts electricity. Why does graphite conduct electricity? Due to A, B, C, or D. Type what you think the answer is and tap on the screen a few times. Yep, I think you guys are getting it. All to do with delocalized electrons in its layers. Let's add that to our notes as well. So graphite conducts electricity. Reason why? Delocalized electrons between the layers, meaning they can carry a charge. Graphene. Okay, so what's the difference between graphite and graphene? What do you guys think? Which answer? Tap what you think. Not tap, sorry. Comment what you think it is and then tap on the screen. Yeah, most of you got this. Graphene is a single layer of graphite. So it's basically looks the same as graphite, but imagine you just looked at one layer. If you get a diagram of just one layer like that, it's graphene. They've got very similar properties. Fullerenes. So there's 2 types of fullerenes you can have. You can have ones that are shaped in a sphere, so like a ball, and another one shaped like a tube. The sphere, that's called Buckminster fullerene. The other one's nanotubes. So the one I've got on this is, we've got the Buckminster fullerene. The nanotubes we'll see in another question, in an exam question. So yeah, they're tubes and spheres, so that means they're completely hollow. They're hollow shapes. That's the key thing about fullerenes, are hollow. And there we go. Here's the hollow one, the nanotube. So you see there's a gap. The structure of fullerene is based on, what do you guys think? Hexagon, octagon, squares, or triangles? You can see, looking at the shape here, 1, 2, 3, 4, 5, 6. Answer for this one's going to be hexagon. Amazing. And next one, the fullerene molecule shown in figure 2 is made of atoms of carbon, hydrogen, and oxygen. Remember, these are allotropes of, all of these are allotropes of carbon. Yeah, well done, guys. So answer is carbon. Hexagons, carbon. Yep, we got all the marks there. In metallic bonding, the electrons. What can we say about the electrons in metallic bonding? A, B, C, or D? What are allotropes again? So while you guys vote, I'll tell you allotropes are same element, different structures. So all of those allotropes are carbon. They're made up of carbon atoms, but they just have different shapes and structures. Yep, delocalized. We've written that on our notes already, so that's fine. What type of crystal compounds do ionic compounds form? Crystal structures, sorry. We haven't mentioned this yet, but it's an additional thing we need to add to our notes. Lattice, yes. Anyone know what a lattice is? Let's add that to our notes. So if we go to back to the notes. Ionic bonding, so ionic properties, we can say, I'm going to need more space here, exist as lattice. Giant lattice. Yeah, they're big. They're basically a cubic structure. We'll see what a lattice looks like in a few questions time. Yeah, it doesn't mean it's big. We call these giant lattice. So the word giant tells us it's big. Lattice means it's a cubic structure and it's 3D. Yeah, it's 3D. So I'll show you in a few questions time. Melting point of covalent molecular substances. Remember covalent, there's two types of covalent. There's molecular and there's giant. So molecular ones, are they going to be high or low? And why is that? So this is where you show whether you've understood what I said about the simple molecular. What do you guys think the answer is? B. So people saying B. Reason, it's not because it's between non-metals, but it is B. The answer is B. Reason is B because, remember what I said, there are strong covalent bonds and there are weak intermolecular forces. The weak intermolecular forces is what gives it a low melting and boiling point, because the weak intermolecular forces don't need a lot of energy to break or to overcome. So low due to weak intermolecular forces. Well done, guys. Okay, here we got a lattice structure. This is a lattice structure. It's a 3D cube. What holds the particles together in sodium chloride? Okay, electrostatic attraction, intermolecular or metallic bonds? Let me know what you think. Tap on the screen a few times. So we got some people saying A, some people saying B. Okay, so most people aren't saying C. So it's either A or B. What do you guys think? Getting a mix of answers here. So first of all, let's identify, is this ionic, covalent or metallic? Sodium chloride, how can we tell? Check which ones are metals and non-metals. Sodium is a metal, chlorine is a non-metal. That makes it ionic. Ionic, let's go back to our notes. We said it was electrostatic attraction, okay? Intermolecular, you only get in simple molecular covalent compounds. This is the only time you use that for talking about melting and boiling point. So it's not intermolecular forces. This is for molecules, for covalent. But because this is ionic, we talk about electrostatic attraction here between the oppositely charged ions. So that's the answer. Solid sodium chloride does not conduct electricity. Give 2 ways in which it can be made to conduct electricity. So we've already realized it's ionic. So when it's solid, ionic compounds do not conduct electricity when solid. I'm going to write it up here. Do not conduct electricity when solid. When do they conduct electricity? That's what the question is asking. So 2 scenarios. Molten, yes. So do conduct electricity. When molten just means melted, or so molten just does mean liquid, or you can say dissolved in water, which we call aqueous. Molten or aqueous, okay? That's the only time that they do conduct electricity. Why is that? Someone's told me already. Because the ions are free to move. Ions are free to move. Thank you for the kind comments, guys. Give 2 ways in which sodium chloride can be made to conduct electricity. So we can say molten as 1. So make it molten, melt it into liquid, or dissolve in water. You can say aqueous. So let's just check what the mark scheme says now. So electrostatic attractions, we got a mark for that. Molten / liquid, yes. Dissolved in water or make it into an aqueous solution. You can say add water as well. What makes graphite a good lubricant? Can't be ionic bonds. What do you guys think? Can't be ionic bonds because it's a giant covalent structure. So what else could the answer be? Yes, remember it exists as layers. These layers here. These layers can slide over each other, which makes it good as a lubricant. Layers can slide, which makes it a good lubricant. So the answer is C. What is the basic structural unit of graphene? So what does it look like, basically, in a complicated way? Three-dimensional network. Someone's put D. We got B. Any other answers? Comment what you think the answer is, guys. Hope you guys know it's definitely not A, because remember that's diamond. Spherical arrangement, it's not spherical arrangement, that's the fullerene. Either B or D. Single layer, it's asking for graphene, not graphite. It's a single layer of carbon atoms in a hexagonal arrangement. Remember, graphene is one of these layers. So this thing here is graphene, is hexagons, and it's one layer. Fullerenes can be used for, so remember these are the spheres or tubes. That's what fullerenes are. What are they used for though, out of all of these? Not making jewelry. It's not, remember this doesn't include diamond. Drug delivery systems, yep. Because you can basically hold the drug, because these are hollow, you can put like medicine, a drug, which is a medical drug, inside the middle of this ball basically, and it can, this atom, not the atom, sorry, the molecule can carry it into the body. So it's used for drug delivery. Which bonding involves positively charged ions in a sea of delocalized electrons? I'm hoping everyone knows this now. We talked about this at the start of the live. Tell me what you think the answer is and tap on the screen a few times. So we're getting C and B. Keep letting me know. We're mostly getting C as the answer. Positive ions, sea of delocalized electrons is metallic bonding. See there? These are delocalized electrons. Let me zoom out a bit. And these plus symbols, they're positive ions. And between both of these, you have electrostatic attraction. So between the positive ions and the electrons, you have electrostatic attraction. And that's what holds the whole metal together. Okay, we've got a 3-marker here. Lithium reacts with chlorine to form lithium chlorides. First of all, guys, which type of bonding are we talking about here? Ionic, covalent, or metallic? Ionic, covalent, or metallic? Let me know in the comments. Lithium chlorides. Remember, think, are these metals or non-metals? We've got 2 people saying ionic, 2 people saying covalent. It's definitely not metallic. What do you guys think? The rest of you think? Think, is lithium a metal? Is chlorine a metal? Or are they non-metals? We've got a few more saying ionic. Lithium, if you look in the periodic table, is a metal. Chlorine is a non-metal. So this is ionic. Okay. So that means electrons are transferred. So we need to mention the electrons being transferred. So look at this first diagram and then look at this second diagram and see what's changing here. What's changing is this electron here. Yep, well done. It's being transferred over here. That's why you've got it in the second diagram here. So we get one mark to say lithium loses 1 electron. Second mark to say chlorine gains 1 electron. What about for the third mark? What do you guys think we can say for the third mark? Any ideas what we can say for the third mark? Why do they have that transfer of electrons? Yeah, you can talk about the charges. You can say chlorine is negatively charged, positively charged. So one thing you can say, Cl becomes negative. Thank you for the likes, guys. Keep tapping the screen. It helps out a lot. Lithium becomes positive. Yeah, you can also mention to get a full outer shell. We've said more than enough for 3 marks here. So we said we got this mark, we got this mark, and it says any one from these. We mentioned, what, 3 different ones. So you can say ions are formed. We said this one, didn't we? Lithium forms positive, chlorine forms negative. Full outer shell, you can say that as well. All right, well done. Let's carry on. Ionic bonds are typically formed between... All right, there's a quick one, guys. Quickly tell me, and we'll move on. We just went through this now, so hopefully you can tell me straight away. A, B, C, or D. Yes, well done, guys. Between metals and non-metals. Okay, explain why calcium fluoride has a high melting point for 4 marks. That is a lot of marks. So now tell me, calcium fluoride, what type of bonding is it? Ionic, covalent, or metallic? Give me your votes. Type what you think it is. Remember, look at what they are. Calcium and fluorine, are they metals or non-metals? So we got people voting for ionic or covalent. It's definitely not metallic. I'm going to make a voting tally chart. So we got 1 for ionic here, 2 people for covalent, 3 people for covalent, 1 for ionic, 4 for covalent. Keep going, guys. Tell me what you think. So far we got 2 people for ionic, 4 people for covalent, 1 more for ionic, 1 more for covalent, another one for ionic. Remember, whether they're metals or non-metals. Look at where calcium is in the periodic table, where fluorine is in the periodic table. Another for covalent. It is actually, so covalent's winning, but it is ionic, guys. It is ionic. The answer is ionic. Calcium is on the left-hand side of the periodic table. Fluorine is on the right-hand side. Let's look at this quickly. Calcium is over here. That's a metal. Fluorine is over here. That's a non-metal. Metal and non-metal means ionic. So this is all to do with ionic property, ionic compounds. Why do ionic compounds have a high melting point? Can anyone remember? What did we say about ionic compounds? Because they have intermolecular forces? No, we don't talk about intermolecular forces. Because remember, that's for covalent molecular substances. Only things as molecules. It's electrostatic attraction. And remember, electrostatic attraction is strong. I think what you guys should do, maybe once I've uploaded this, I think maybe you guys should go through this again. Go through the live again from the beginning. And make notes on it. And it'll help you remember everything. So strong electrostatic attraction. That's 1 mark. What else can we say? We need 4 points here. What are the strong electrostatic attraction forces between? They're between... What's my YouTube is the same. Flash Revision Lab on YouTube, guys. Subscribe. And I'll put all these lives up. I'll cut them down and I'll put all the notes and all the questions up, and I'll put flashcards. So I changed all these questions. I've got a printable version that's like flashcards, so you can print them off and cut them out if you want and turn them into flashcards. So you look at the question on one side, flip it over, and the answers on the other side. It's useful for some people. So strong electrostatic attraction between, remember, it's between oppositely charged ions. So you have a positive ion and a negative ion. And what else did we say about ionic compounds? Let's look back at our notes. What did we say about ionic compounds? About their properties. So we said they have strong electrostatic attraction. We mentioned that. And there's a large amount of energy needed to overcome. We said the electrostatic attraction is between oppositely charged ions here at the top. They're strong. They need a large amount of energy to overcome. So we probably should mention that. And also, they exist as giant lattice structures. You don't get a mark for saying high melting point or boiling point because it already says so in the question. So there's no point saying that same information again. So we don't need to say that. So we can say it's a giant lattice structure and we need a lot of energy to break those forces, or break those bonds. Okay, let's look at what the mark scheme says, if there's any other things we can say. Strong electrostatic forces of attraction, yes. Or you could just say ionic bonding actually. If you figured out that it was ionic bonds, you get 1 mark for saying that. Between oppositely charged ions, yes. Or you could say between the 2 ions that they're talking about. Giant lattice structure, yep, we got that mark. A lot of energy is needed to overcome or break this attraction. 4 marks there. Next question. Covalent bonds are formed by... This is a quick one, guys. So these questions are repetitive because that's how it sticks in your head. So I'll go through the notes. I have all these questions, these straightforward questions where there's no risk. If you get it wrong, nothing happens. But hopefully by doing loads of these repetitive questions, it sticks in your head and it helps with the revision when it actually comes to the exams. How many questions are left? Not many. It's been an hour already. A few more. We've got to go through these quite quickly now. Non-metals, yep. Well done. Next question. Which of the following is a property of simple molecular substances? We mentioned this as well. What do you guys think? A, B, C, or D? Vote and tap on the screen. Can the mark scheme apply to other ionic compounds? Yes. Any ionic compound, when they ask you why do they have high melting points, you can use those same 4 points. Answer here is D. They have low melting and boiling points. Good. diamond is an allotrope of, we've had this question already, but for, I think it was a fullerene. So this should be a quick one. It is B, carbon. Well done, guys. Few more, nearly done. Simple molecular substances are the forces between, in simple molecular substances, the forces between the molecules are, okay, let's see if you guys understood what I said about simple molecular forces. So then remember, they're not electrostatic. They're different to electrostatic forces. I will upload this on YouTube. Yes, guys, I've already uploaded the moles ones, the cells one, and the electricity one. I will upload tomorrow, yeah. And then there's one on specialized cells that we did on Sunday. I'll upload that this week as well. Answer is C for this one. So yeah, guys, subscribe to my YouTube channel and you'll get access to all of these questions and the notes as well. Why don't simple molecular substances conduct electricity? What do you need for something to conduct electricity? You don't need to know what non-polar is. This is A-level stuff, guys. Don't worry. It's definitely not C. That's A-level stuff. They have no free electrons or ions. Okay, so this is one thing I want to point out, guys. If you get a question asking why something doesn't conduct electricity, you don't just say it doesn't have free electrons. It has to be electrons or ions. So no free electrons or ions, because they need one of the two to conduct electricity. So free electrons, that's things like graphite has free electrons, that conducts electricity. Graphene has free electrons, that conducts electricity. And metals. So the reason why these conduct electricity is because they have free electrons. Free ions, these are ionic compounds. So anything with ionic bonds, which are molten or aqueous, the reason they conduct electricity is because they have free moving ions. So don't get confused between the two, because I've seen so many times where people say ionic compounds conduct electricity because they have delocalized electrons. But that's not right. It's because they're free moving ions. Live videos, yeah, they are being uploaded on YouTube. I've uploaded last week's ones, last weekend's one. So this Friday and this Saturday's one I'm going to upload tomorrow. But I've uploaded the week before's one. So I will do, guys. Don't worry. It takes a long time because they're obviously like an hour long, and I need to edit them. I try to like make it like as quick to watch as possible. So I cut out all the pauses and stuff. So it takes a while. It's not, I don't just upload it straight away. But yeah, I will do. I'll do the electricity one from Friday tomorrow. And then there's one more, the specialized cell one. I'll try to do that the day after. And then I'll try to post this before Friday's live. So next live is on Friday at 8:30. Next question. Which of the following is an example of a simple molecular substance? Let me know what you think. We've got mixed answers. Most people saying C. Somebody saying D. Okay, I can see why people say D, but we saw this earlier. We saw silicon dioxide. This is a weird one. Loads of people would think this is simple molecular, and I understand why, because silicon is a non-metal, dioxide is non-metal. But remember this as a one-off. Silicon dioxide is the one that looks like diamond, the one that we saw earlier. If you don't know what I'm talking about, once I've uploaded this on YouTube, go back and watch it. We have silicon dioxide. It looks just like diamond. So silicon dioxide is actually giant covalent. It's not simple molecular. So that's one to think of as a one-off. That's a one-off. No, we did electricity last week. Last Friday we did electricity. So I'll upload that tomorrow. This Friday we're going to do something else in physics. Probably, let me think, either energy or radioactivity. I have to think which one we're going to do. Okay, so this one here, sodium chloride is ionic, not ionic. Diamond is also giant covalent. So diamond and silicon dioxide have the same structure. So the answer is, yeah, well done, water. And this is our last one, guys. Let me know. Tap on the screen a few times. Let's get a few more likes before we finish. And so I'll tell you guys, follow subscribe to the YouTube. If there's any like specific questions, let me know now. Actually, what are you guys interested in? So for biology, I think the next one we're going to do is on bioenergetics, because that's really important for paper 1 and paper 2. So that's respiration, photosynthesis. I'll go through that. And then for next chemistry, maybe we could do electrolysis probably, and radioactivity and electrolysis. Okay, I'll try and probably do that as the next two lives. Let me know if there's any other questions, guys. Titrations, yeah, I'll try and do that at some point. That will be maybe in 2 weeks' time. Right, so next chemistry live will be on electrolysis. I know that's a tough one. All right, no other questions. Let me know what you think the answer is. What happens when a simple molecular substance changes state? So that means when it's melted or boiled. Melting point and boiling point, what did we talk about? Simple molecular. So remember, this is the one with the 2 different bonds, this thing here. Which ones are broken? We said they had low boiling point because it's the intermolecular forces that are broken. So the intermolecular forces are overcome. The final answer is C. All right, well done, guys. I'm going to be off now. So I will see you guys on Friday then. So look out on my YouTube for the lives that I'll be posting, and I'll be posting a few more videos, a few more quizzes this week as well. So yeah, thank you guys. Thank you for the comments, and thank you for joining. What am I doing on the Friday? What am I doing on Friday? I'm doing, what did I say, physics? I think I'll probably do radioactivity, because I'm trying to pick like the harder ones to do, the ones that people will struggle with the most. So I'll probably do radioactivity. All right, thanks guys. I'll see you on Friday. Have a good evening.